Hello everyone. In this video lecture, we are going to discuss about ethylene derivative and alkyl amine antihistamines. So in previous lecture we have seen one of the important chemical class under antihistamines. Okay, so ethylene diamine derivatives and alkyl amines are also the important chemical class under antihistamine chapter. Okay, so let's see what is the chemistry of ethylene diamine derivatives and alkylamine antihistamines. Okay, so under antihistaminic chapter or antihistamine chapter, the important class ethylene diamine derivative. Okay, and the two important drugs under this class are triplenamine hydrochloride and phenbenzamine. Okay, so as per your syllabus point of view, two important drugs are there. Okay, so that is triplenamine hydrochloride and phenbenzamine. So let's see the chemistry of the drug. So ethylene diamine derivatives are characterized by the presence of nitrogen connecting atom and a two carbon atom chain as a linkage between the key diaryl amine and tertiary amino moieties. Okay, so in general structure you can see there is a presence of ethylene chain. Okay, ethylene chain in between diaryl amine group and the tertiary amino group. So in between these two nitrogen there is a linkage which is present. It's made up of two carbon atom which is a ethylene. Okay, then there is a presence of diaryl substitutions on nitrogen, that is diaryl amine. Okay, and to the next side there is a presence of tertiary amino group. Okay, so keep it in mind related to the chemistry of the ethylene diamine derivative or the one of the important class under antihistaminic agent is ethylene diamine, in which there is a presence of diaryl groups attached to the nitrogen, that is diaryl amine, and to the another side there is the presence of tertiary amino group, and the connecting linkage of two nitrogen is made up of two carbon atom, that is ethylene diamine. So that's why that complete structure or complete class having the name as ethylene diamine derivative. So let's see the structural activity relationship of this class. So the one of the drug under this class, that is phenbenzamine, was the first clinically useful member. Okay, so the drug which came into existence first is phenbenzamine. So it was first clinically observed the antihistaminic activity. Okay, so it is the first clinically useful member this class and serve as a prototype for the development of more effective derivatives. Okay, so after the phenbenzamine there are number of drugs came into existence, but this is the first clinically useful drug. Okay, and that phenbenzamine act as a prototype for the development of more effective derivatives. Okay, after that there are number of more effective derivatives came into existence, but this phenbenzamine is a important drug. Okay, which is first clinically useful and act as a prototype. So replacement of the moiety of phenbenzamine with a 2-pyridyl system yielded triplenamine, a significantly more effective histamine receptor blocker. So antihistamine drug having the activity towards histamine receptor, mainly H1, H2, H3. Okay, there are different receptors are there. We have seen different receptors, their locations. Okay, but antihistamines are the drug that bind to the receptor and blocks the receptor. Okay, so there it must having the affinity towards the histaminic receptor. Okay, so initial drug is phenbenzamine. So after in that structure there are some modifications have been carried out. Okay, and due to the modifications into the structure, the new drug which came into existence is triplenamine. Okay, so what is the modification they have done in the structure? So they have replaced the moiety of phenbenzamine with a 2-pyridyl system. Okay, and due to the replacement of the phenbenzamine moiety with 2-pyridyl system, it yielded a new drug which is a triplenamine, and it having significantly more effective histamine receptor blocking activity. Okay, so in the structural activity relationship we have to explain that due to the replacement with 2-pyridyl system, the new drug having the more effective histaminic receptor blocking activity. The next point, substitution of para-methoxychloro or bromo further enhances activity. So this type of electron withdrawing groups like chloro, bromo. Okay, so due to the presence of this type of groups, okay, at para due to the substitution of para position with methoxy, chloro or bromo group enhances the activity. So in exam they may ask like what is the effect of presence of methoxy, chloro or bromo group in the para position. So you have to explain that due to substitution of para methoxy, chloro and bromo, there is enhancement in the activity. Okay, then third point is replacement of the benzyl group of triplenamine with a 2-thionyl methyl group provided methapyrrolene, and replacement of triplenamine's 2-pyridyl group with a pyrimidinal moiety with paramethoxy substitution yielded thonzilamine. So it produces new drug which is a thonzilamine, both with functions as potent H1 receptor antagonist. Okay, so it explains if there is a change with the different heterocyclic ring, it enhances the H1 receptor antagonistic activity. So in all of these compounds, the aliphatic or terminal amino group is significantly more basic than the nitrogen atom bonded to the diaryl moiety. The non-bonded electrons on the diaryl nitrogens are delocalized by the aromatic ring. So the resultant reduction in the electron density on nitrogen decreases the density and due to that the decreases the basicity of the drug. So thus the aliphatic amino group in the ethylenediamine is significantly basic for the formation of pharmaceutical useful salt. Okay, so you can see in this sentence, so the resultant reduction in the electron density on nitrogen. Okay, so the basicity is one of the important criteria related to this class. Okay, so there is a presence of nitrogen, and on nitrogen there is a reduction in the electron density. Okay, so aliphatic or terminal amino group is significantly more basic than the nitrogen atom bonded to the diaryl moiety. So in the structure there is a presence of diaryl moiety. Okay, and due to the presence of diaryl moiety, there is a decrease in a basicity. The non-bonded electrons on the diaryl nitrogens are delocalized by the aromatic ring. So due to the change in the substitution, okay, that instead of aliphatic substitution there is a presence of aryl moiety. Okay, and due to the presence of aryl moiety there is a significant less in a basicity on the drug. Okay, so one important concept related to the acidity or basicity is due to the presence of aliphatic substitution on the terminal amino group, or terminal amino group is significantly more basic if there is a presence of aliphatic substitution then the nitrogen atom bonded to diaryl moiety. So if there is a presence of diaryl moiety of the nitrogen, then that nitrogen becomes less acidic. Okay, or the basicity of that nitrogen increases. The aliphatic amino group is in the ethylenediamine is significantly basic for the formation of pharmaceutical useful salt. Okay, so this is the reason behind the formation of pharmaceutical useful salt. Okay, so the drug under this class is triplenamine, histamine H1 antagonist with low sedative action but frequent gastrointestinal irritations. Okay, so mainly triplenamine having the activity at H1 receptor. They bind to the H1 receptor and blocks the receptor, and it produces antagonistic activity. So it is used for the treatment of asthma, then urticaria and rhinitis, and also in the veterinary application. So triplenamine is administered by various routes, including topically. Okay, so topical different creams or lotions are also available. Okay, so the main action of the triplenamine is on the H1 receptor, that is H1 antagonistic activity. So this is the structure of the drug. Okay, you can see in this structure there is a presence of two carbon atom in between nitrogen. Diaryl nitrogen is present. Okay, so both aryl rings are different. On nitrogen there is a presence of benzyl substitution. Okay, there is a presence of 6-member homocyclic ring carbon, which is made up of carbon atom with CH2 group. So it is a benzyl substitution. Then another aryl ring is pyridine, 6-member ring with 1 nitrogen. Okay, so it is a pyridine ring. So it made up of diaryl amine group. Okay, as in structural activity relationship we have seen. Okay, there is a diaryl amine group is present. Then next one is tertiary amino group. So tertiary amine and the diaryl amine attached to each other with the help of linker made up of 2 carbon atom. So this is a chemistry point of view of the drug. Okay, so the nomenclature for the drug is N-benzyl, NN, dimethyl, N, pyridine, 2YL, ethane 1,2-diamine. Okay, so as there is a presence of 2 carbon containing chain or linker in between 2 nitrogen, so it is a ethane, then 1,2-diamine. Okay, so this is a nomenclature of the drug. As a chemistry point of view, you have to explain there is a presence of 2 carbon containing linker in between nitrogen, which is very very important for the activity, which enhances the activity at histamine receptor. Okay, then there is a presence of diaryl substitutions on the nitrogen, okay, which is required for the antihistaminic activity and the affinity of the drug towards histamine receptor. So triplenamine hydrochloride is a white crystalline powder that darkens slowly on exposure to light. Okay, so it is a white crystalline powder. Appearance of they are available in the form of crystalline powder. Okay, so that is darkens slowly on exposure to light. So if they expose to light, they converts into dark shade. Okay, the salt is soluble in water and in alcohol. So this is a solubility point of view of the drug. Okay, soluble, completely soluble in water and in alcohol also. It has a pK of about 9. So 9 pK. Then triplenamine, the first ethylenediamine developed and is well absorbed when given orally. Okay, so as compared to different oral routes are there, so oral route is also preferred. Okay, and this is the first drug which came into existence, which is orally active antihistamine. Okay, well absorbed when given orally. So phenbenzamine, next drug is phenbenzamine, is a liquid. So phenbenzamine is an aromatic amine having antihistaminic activity. Okay, bind to the histamine receptor and blocks the receptor, and ultimately they inhibits the actions produced by the histamine. So the mechanism of action remains as it is. Okay, that binds to the histamine receptor, blocks the receptor, and blocks the binding of histamine to the receptor. Due to the binding of drug, whatever site is there, that is blocked, and due to that the histamine is not able to bind, and ultimately the actions which are produced by the histamine will not occur, or histamine induced action, there is a decrease in histamine induced activities. So phenbenzamine is a ethylenediamine derivative which came into existence first, which having the antihistaminic activity. So this is the structure of phenbenzamine: N-benzyl, NN, dimethyl. Okay, so on nitrogen there is a presence of substitution of methyl. Okay, so NN, dimethyl, N, phenyl ethane 1,2-diamine. Okay, so in this case also there is a presence of diaryl substitution on nitrogen, so diaryl amine group is there. Okay, so in previous structure, that is we have seen there is a presence of pyridine nucleus, 6-member ring with one nitrogen, that is a pyridine nucleus. Okay, so first drug which came into existence is a phenbenzamine. Okay, so in that phenbenzamine, whatever phenyl ring is present, that phenyl ring is substituted with pyridine, and due to the change in the structure, that conversion of phenyl ring or substitution of phenyl ring with pyridine, it enhances the activity. We have seen in structural activity relationship. So you can see, if they ask what is the difference between triple-enamine structure and phenbenzamine structure, so you have to explain that in the phenbenzamine came into existence first. Okay, so the activity of the drug, to enhance the activity of the drug, there is a substitution of the phenyl ring with the pyridine nucleus. So due to that, they enhances the activity, having the potent antihistaminic activity. Okay, so this is just change in the structure, is that change in a phenyl ring with pyridine nucleus. Remaining structure is as it is. Okay, so there is a presence of two carbon containing chain in between two nitrogen as a linker. Okay, then there is a presence of substitution on nitrogen, methyl substitution, dimethyl groups are present. Okay, so the remaining chemistry remains as it is. The next class is alkyl amine or propyl amines. Okay, alkyl amine is a general term. So propyl amine made up of 3 carbon atom and then next nitrogen. Okay, so alkyl amine or propyl amine. So these are the examples, that is chlorpheniramine maleate, then tripronidine hydrochloride and phenidamine tartarate, which is a salt form. So if we are going to write about chlorpheniramine maleate, so it is a salt form of chlorpheniramine. Then tripronidine hydrochloride is a salt form of tripronidine. Then phenidamine tartarate is a salt form of phenidamine. Okay, so first one is, what is the structural activity relationship for propylamines? The propylamines antihistamines are characterized structurally by an sp3 or sp2 carbon connecting atom with a carbon chain of 2 additional carbon linking the key tertiary amine. Okay, and diaryl pharmacophore moieties. So those propylamines with the saturated carbon connecting moiety are commonly referred to as phenyramine. Okay, so this is an important point, having the sp2 carbon connecting atom with carbon chain of the 2 additional carbon. So all of the phenyramine consist of phenyl and 2 pyridyl aryl groups and the terminal dimethylamino moiety. Okay, so it having the phenyl substitution, then 2 pyridyl aryl group, okay, and the terminal dimethylamino moiety. So dimethylamino moiety is important, then diaryl amine functional diamine moiety is also important. So these compounds differ only in the phenyl substitutions at the para substitution or para position. Okay, so phenyl substitution at para position is important. Okay, in the phenyramine at para position there is a presence of hydrogen. In chlorphenyramine there is a presence of chlorine. Okay, on the phenyl substitution, okay, whatever phenyl group is present in this propylamine group, on that phenyl substitution there is a change in the para position. On the phenyl there is a change in the para substitution with hydrogen, then it is phenyramine. Substitution with chlorine, then it is chlorphenyramine. If there is a substitution of para position of phenyl group with bromine, then it is bromphenyramine. Okay, these are the important point. Okay, the halogenated phenyramine are significantly more potent, 20 to 50 times, and have a longer duration of action. Okay, so due to the change in the substitution of the phenyl group or phenyl ring at para position, it enhances the antihistaminic activity. The newer drugs which came into existence having longer duration of action. Okay, so in structural activity relationship you have to explain that in the propylamine structure phenyl ring is present. On that phenyl ring, substitution of para position with hydrogen, chlorine, bromine enhances the activity. The newer drugs are more potent and it having the longer duration of action, 20 to 50 times more potent. Okay, so these are the important point. The propylamines with an unsaturated connecting moiety includes the open derivatives pyrobutamine and triptolylene and a cyclic analogs dimethindine and the phenidamine. So these are the open chain propylamine. A coplanar aromatic double bond system appears to be an important factor for antihistaminic activity. So it having the antihistaminic activity. The pyrrolidino group of these compounds in the side chain tertiary amine that imparts greatest antihistaminic activity. Okay, so due to the presence of pyrrolidino group, okay, on the side chain tertiary amine that imparts the greatest antihistaminic activity. So the conformational rigidity of the unsaturated propylamine has provided a useful model to determine distance between the key diaryl and tertiary pharmacophoric moieties. In the H1 receptor antagonist, distance is 5 to 6 angstrom. Okay, so this distance is also important. The histamine in this group are among the most active H1 antagonists. The agent in this class also produce less sedation than the other chemical antihistamine. So this is a drug that is chlorpheniramine. Then brompheniramine and chlorpheniramine maleate are first generation antihistamine. Okay, both are first generation antihistamine. Okay, what is the difference between brompheniramine and chlorpheniramine? Just there is a presence of bromo group at para position on the phenyl, and in chlorpheniramine there is a presence of chloro group at the para position on the phenyl. So they are first generation antihistamine, as they are first generation having some side effects, okay, like sedation. So they are mainly used in a treatment of symptoms of the allergic rhinitis and common cold. So chlorpheniramine maleate appears as odorless white crystalline solid or white powder with a bitter taste. Okay, having bitter taste. Then the appearance is in the white crystalline solid. Okay, then color is white. So it is available in the crystalline solid powder. Okay, white in color and bitter in taste. So having the H1 antagonistic activity that bind to the H1 receptor and blocks the receptor and produces a H1 antagonistic activity. So it is used to relieve the symptoms of hay fever, rhinitis, urticaria and asthma. So it has a role as an H1 receptor antagonist and antipyretic drug, a histamine antagonist, a serotonin uptake inhibitor, an antidepressant and an anti-allergic agent. So these are the different medicinal uses of the chlorpheniramine. So as a structure you can see in propylamine there is a presence of linker or connecting uh, chain made up of 3 carbon atoms. So it is a propylamine. Okay, so in between nitrogen there is a presence of specific propylamine group is present in their structure. So it is a 3,4-chlorophenyl. The chemical nomenclature for the chlorpheniramine is, okay, one more important point related to the chlorpheniramine you can see over here. In the phenyl ring there is a presence of chloro group at para substitution. Okay, so due to the para substitution of phenyl with chlorine, the drug which came into existence is chlorpheniramine. So the chemical nomenclature for the drug is 3 in bracket 4-chlorophenyl. At third position there is a presence of substitution, that is chlorophenyl substitution is present at third position. Then NN dimethyl on nitrogen there is a presence of substitution with methyl. 2 methyl groups are present on nitrogen, so it is a dimethyl. Then 3 pyridine. Okay, so it is a presence of substitution of pyridine, that is a 6-member ring with 1 nitrogen, so it is a pyridine. 2 while propane. Okay, so 3 carbon containing chain, so it is a propane 1 amine. So this is a nomenclature of the drug. So chlorpheniramine is a tertiary amino compound, that is propylamine, which is substituted at position 3 by a pyridine 2-vial group and a para-chlorophenyl group, and in which the hydrogens attached to the nitrogens are replaced by methyl groups. Okay, so coordination of pheniramine in the para position of the phenyl ring increases the potency tenfolds with no appreciable change in the toxicity. So this is a very important point related to the chlorpheniramine. Okay, in pheniramine and chlorpheniramine, if we are going to consider Okay, what is the difference in between chlorpheniramine and pheniramine? In pheniramine, there is a presence of hydrogen. In that, para position of phenyl ring is replaced with chlorine group, and due to the chlorination of pheniramine, the newer drug which came into existence is chlorpheniramine, having increased potency. So the important point is one that there is an increase in the potency 10 folds, and one more important point is no appreciable change in the toxicity. There is no any change in the appreciable toxicity. So appreciable change in the toxicity means if phenyramine having specific toxicity, okay, so that try to minimize those toxicity. So there is no any appreciable change in the toxicity, but there is an increase in the potency or increase in the activity of the drug. So it is a tertiary amino compound, a member of monochlorobenzenes, a member of pyridines. The next drug is triprolidine. So it is a first generation antihistamine that is used for the symptoms of allergic rhinitis and common cold. Okay, and it is also having short acting sedative property, as it is first generation, having some side effects like having sedation side effects. Okay, so it is a sedating antihistamine that is used generally as the monohydrate for the relief of the symptoms of urticaria, rhinitis and the various pruritic skin disorders. So this is the structure of triprolidine. Okay, you can see there is a presence of pyridine nucleus. Okay, then there is a presence of 4-methylphenyl substitution. Okay, so as a chemistry point of view, you have to explain which are the different substitutions are present. So pyridine nucleus is present, then there is a presence of 4-methylphenyl ring, then also there is a presence of pyrrolidine structure. Okay, so due to the presence of pyrrolidine, which is a 5-member saturated ring without any double bond, okay, 5-member ring with one nitrogen. Okay, so due to that, the name of the drug is triprolidine. Due to the presence of pyrrolidine nucleus or pyrrolidine heterocycle in the structure, the name of the drug is triprolidine. Okay, so there is a presence of substitution at second position. Then there is a presence of 1 in bracket 4-methylphenyl. Okay, presence of methyl group at 4th position, so it is a 4-methylphenyl. On first position, there is a presence of 3 carbon containing chain, okay, which is a propyl chain. So on that propyl we have to number 1, 2, 3. So at first there is a presence of this substitution. Okay, then pyrrolidine group is present at 3rd position, or pyrrolidine ring is present as a substituent at 3rd position of the 3rd number of the carbon chain. Then 1 prop 1 enyl. Okay, so there is a presence of double bond, so it is in. Okay, and then YL. So if there is a methane, then if present in substitution, then we mention as methyl. So similarly like that, it is a propyl, but there is a presence of double bond, so it is propane 1 in YL, propenyl pyridine. Okay, so there is a presence of pyridine nucleus in the structure. So this is a chemistry point of view of the triprolidine. So triprolidine is an alkyl pyrrolidine, that is acrevastine, in which the pyridine ring is lacking the propanoic acid substituents. It has role as an H1 receptor antagonist. It is an alkyl pyrrolidine, a member of pyridines and an olefinic compound. So this is a triprolidine hydrochloride, which is a hydrochloride salt resulting from the formal reaction of equimolar amount of triprolidine and hydrogen chloride. Okay, so it is converted into their hydrochloride form, okay, by mixing or by formal reaction of equimolar amount. Okay, so this is important, that equimolar amount of triprolidine and hydrogen chloride, okay, and the formal reaction of this both the equimolar concentration results in the new salt form of the drug, that is triprolidine hydrochloride. So it is monohydrate is used for the symptomatic relief of urticaria, rhinitis and various pruritic skin disorders. Okay, so it has a role as an H1 receptor antagonist. So it is an alkyl pyrrolidine and a member of pyridines. So it is as it contains a pyridine nucleus, it is a member of pyridine. They may ask in the exam, give the structure of the antihistamine, which is a pyridine, which is a pyridine derivative or member of pyridine, which is a propylamine. Okay, so under propylamine, the pyridine derivative is tripluridine. You can say, you can give the structure. Okay, just equimolar concentration of tripluridine and hy- clo- and the hydrogen chloride mixed together, and the reaction, formal reaction produces the tripluridine hydrochloride, which is the hydrochloride salt of the tripluridine, having the activity similar to that of the tripluridine. Okay, just for the increasing bioavailability, for the to cross the membrane, it converted into the salt form to enhance the bioavailability of the drug. Then next drug is phenidamine. Phenidamine occurs as a creamy white powder, usually with a faint odor and sparingly soluble in water. Structurally, phenidamine can be regarded as a unsaturated propylamine derivative. Okay, so it is unsaturated. It contains presence of double bond, that is rigid ring system contains a distorted transalkyl. So like the other commonly used antihistamine, it may produce drowsiness and sleepiness. Okay, as it is first generation drug, it having some side effects, mainly it having the drowsiness and sleepiness side effects. So it's commonly used in other antihistamine, it also having the same side effects. So it may also cause some mildly stimulating actions in some patients in and insomnia when taken just before bedtime. Okay, so administration time is also important. If the drug is administered just before the bedtime, then it lead to the insomnia. This is important point related to the drug. So this is the structure of the phenidamine tartrate. Okay, so this is a, as we have seen, alkyl amine, which is one of the important chemical class under this antihistamine chapter. Okay, so we have seen two important chemical classes. In last lecture we have seen different histamine receptor, their locations. Then one of the important class also we have discussed in previous lecture. Okay, so this is an important chemical class. So remaining class under this chapter, that is antihistamine, we'll see in next lecture. Thank you.